Hello everyone. Welcome to another video. This is actually me, your host, Spar Brian, and I'm not putting up a show. I just want to let you guys know that if you really want to see more things about it, you can actually check out my Scratch account. Here's my Scratch account over here. The name is Spar Rajat right here. Spiner Rajat. That's my Scratch account. Now, if you guys really want to follow through, you can actually talk through the comments here. I have no problem at all um, talking about it, and I've already had actually said about 7 months ago. Anyone can subscribe to my YouTube channel, and yeah, that's why I just only have two. It's because I only uploaded just one YouTube video, and I'm definitely gonna upload this one. So people who actually love Scratch most also love Scratch Cat as well, the cat from Scratch programming. You can actually just go into this one, and it's not about only just US, as you might actually see this MIT. Scratch is actually from MIT Studio, so, but actually it is more likely amazing. And I'm also working in progress about this game over here. This is called Paper Minecraft, but it's actually the textures. I'm actually like trying to change the textures so that it actually looks like it's made out of clear plastic toys. So yeah, that's what I just you guys can actually listen to this podcast trailer. This is the podcast here. It's called Minecraft Citycraft.io podcast. It will be coming up probably as a new playlist. So if you guys really want to tune in order to get this over with, I'm happy to help in that. But actually, that's not. This video is actually just to tell you guys exactly that you can also check out my projects. Here are some of my favorite projects here. No, actually, it's this one here. This I have made a lot of projects, and some of them are actually about the friends who actually, have actually friends with. So yeah, I actually have made a tons of them. These are only the projects that I've actually shared. Um, and here it is. This is my character here. That's definitely my character. I have no problem if you are actually like don't really want to subscribe to my YouTube channel, and you sort of like hate my videos, but that's okay. That's definitely fine with me. Here it is. Here's the skin. I'm actually okay if you don't really like my videos. So yeah. And yeah, let's get this over with. So this will actually gonna become the second video. Here's actually this video of it's already reached 90 views. It was only 1 month ago. Okay, so let's actually just do this one, shall we? So what we're gonna do today is we're gonna be talking about this is actually based on maths. Let's do some maths, boys. So, okay, it's actually for boys and girls, but not just boys only. What we're gonna do today is we're gonna be talking about discrete data versus continuous data. Continuous data. Okay, so there are some differences between discrete and continuous data. It's based on actually one similarity is that this is actually based on statistics. So it's more like math statistics. Although I'm not really a fan of statistics, but I decided to put up this one because this is like an easy concept to understand about it and this thing. So like when like in the exam, you would not really know about this one. Like you would get a graph, and you would actually be given a histogram, or a bar graph, whatever they call it. Um, and they would actually ask the question if it's actually discrete or continuous data. And we're going to use actually some examples, some examples. Some of them may be real life, some of them may be, well, your everyday things that you actually do in your life. So first of all, discrete data is actually they actually are more likely like natural numbers. So like for example, one, let's say one apple, and we now have two apples. One, two. So actually, discrete data, three apples. I'll just draw three for timing. One, two. They don't really look like apples, but just as a rough diagram, three. So discrete data is actually, number one, countable. They are countable. There actually are some things that I don't understand. Discrete data can sometimes be countable, sometimes they cannot be countable. But in this concept, discrete data is only just countable. Continuous data. Actually, you know what? Let's just talk about discrete data, and then we'll move on to continuous. So first of all, discrete data can be counted. Like if you really want to know exactly how many apples are there, I can say, oh, we actually have, let's say, what's actually the total apples? Let's see, 1, 2, 3, 4, 5, 6. 6 apples. I have 6 apples in whatever, my suitcase or bag or lunchbox. So the data can actually be counted. That's actually discrete data. They can be counted. That's only just one difference. In continuous data, yeah, the numbers can be counted, but sometimes continuous data are actually like data that can be measured. So, like for example, let's say, how much time do you actually heat up the milk? Well, usually for in my everyday life, when actually it comes to actually drinking milk, I heat 1 cup of milk, and let's say, so actually here's my cup. Here's my cup of milk. Hot beverage. And here, this is not a microwave, but I'm just drawing just like that. It shows a microwave. So the time that I actually put in here, there's some buttons. That it almost looks more like a TV screen, but it's not. The time that you would actually put in here, is actually 1 minute. 1 minute. Some people, when it actually comes to heating lunch, the thing is we don't really use any other equipment other than the microwave. We always rely on the microwave itself. When it actually comes to, let's say, heating up, heating up a bowl of noodles. You know what? I'll just make something that actually looks more like noodles. There we go. We just got a spoon in here. So, in order to record the time for actually this one, is actually 1 minute. The time that it should take to heat up this is actually 1 minute and 30 seconds. Wait. 1 minute and 30 seconds. 1 minute and 30 seconds. The reason why I actually want to include in here is because continuous data is not just like, it's not that they can be counted, it's that they can be measured. And if we actually talk about in minutes for the time being, like 1 minute and 30 seconds, some people would actually say, you know what? In order to heat a bowl of noodles, I should actually put the time of 1.5 minutes. Well, but in the microwave, you don't have like an option where you could put 1.5 minutes. You just put 1 minute and 30 seconds. But that's what the person actually meant. There can actually be sometimes like when you count the time, when you actually like, you don't know how much time is left for you to go outside to well, actually play baseball or rugby or basketball. So how much time is actually left? You actually count in minutes, hours, seconds. Well, actually not seconds, because actually the clock only has two hands. One is minute and one is hour. So actually what I wanted to say is that the continuous data, they can be measured. They can be measured. Like, think of it yourself, not just time. Time can actually only have minutes, seconds, hours. I wish there was also kilohours, but there's nothing like that. You can also have weight. For example, how much weight have you lost? How many grams have you actually lost? Well, I could say that well, for example, I have lost 1,000 grams or kilograms of my fat, which is definitely not true. But actually, the grams is actually the measurement. Also, I just want to include the second thing. They can not only be natural numbers. So actually, first of all, discrete data only includes natural numbers. Natural numbers. Like, for example, 1, 2, 3, and definitely a lot of. But actually, in continuous data, you have 1, 2, 3. Yeah, also natural numbers, but also you have real numbers. Like, for example, you have decibel. Did I say decibel? That's a funny term that I just used. Maybe they should actually use a Minecraft mob. What I meant to say is actually decimal numbers. They can be decimal numbers. Why did I write decimal? I'm so bad at spelling. Decimal numbers. They can also be like in other words, what I actually meant is actually real numbers, right? If you actually just wanted to explain itself as fractions and other things, so like for example, in order to like set the time for like in order to heat the bowl of pasta, right? You have to be at you have to like put up the time of 1 minute and 30 seconds, which means it would be 1.5 minutes, or actually if you want to say in fractions, it'll be 1.5 minutes, right? Yeah. So there you have it. You have discrete data and you have continuous data. Now what we're going to do today is now we're going to actually put up some examples. We're going to actually put up actually some example charts, and we're going to see exactly if you could actually just figure this one out. So what I'm going to do is I'm going to hide that and put a new layer. Okay. So let's say I just had this graph here. Oh, why did I put that there? No. Somehow I kind of hate the way the screen actually disappears and appears all the time. It's just my toolbar just disappearing and appearing. I have no idea why. Okay, so let's say. Actually, sorry, it's my mistake. I didn't mean to say bar graphs. What I meant to say is that let's say we actually come up with some examples. So let's say, shoe sizes. Pause the video and see if you can actually figure out which one is descriptive. Sorry. I'm so terrible at words, sorry. Pause the video and try to figure out which one is discrete and which one is continuous data. Well, I think you're right. You are right, because shoe size is continuous. Continuous data. You can actually count the number of shoes, but when it comes to sizes, the shoe size, it is actually continuous. So actually the number of shoes is actually discrete, but shoe size, it's supposed to be actually continuous. Next question. How much time does it take for an eruptive volcano to how much time does it actually take for the volcano to erupt? So actually, how much time? Let's say, how long will it actually take for the volcano to say just be quiet for the time being? Right. So, how much time will it have to take for this volcano to just become like this? Just bits of smoke coming out, but nothing at all. Just plain. How much time would actually that take? Well, that is continuous as well. Time can actually, you know what? Volcanology, which actually I love volcanology, including plus I like volcanoes. Also, I'm living next to a volcano, not an active one. Time, when actually scientists actually mention that, is actually continuous data. It can actually be half a second. It can be, well, actually, there's no way you can say well, yes, you could say half a second. But when you actually say 1 second, then say half of it, I don't think you could say that. Time is actually continuous data. Time is continuous data. Continuous data. Next question. I'm going to make sure this is going to be discrete. I'm going to do that in purple. Let's say that in your family, you actually have a number of siblings. What is the number of siblings for each student? So let's say one student over here has two sibs. Let's actually use I'm just gonna use sib in order to actually, in short, to say siblings. So let's say there are two sibs for this student, and we have another student which only just has one sib, and this student over here which is actually me, has 0 sib. I have no siblings at all. Don't ask further questions. You can ask further questions through my Scratch account, which is actually in the comments. So what I actually meant is actually the number of siblings for each student in Kennedy's in Kennedy High School. Kennedy High School. I just came up with that term. If that's real, just let me know. Kennedy High School. The number of siblings for each student in Kennedy classroom. Kennedy High School. Well, actually, that is discrete. Why? Well, actually, don't think that sib is actually a measurable term. I just use that in order to just say in short for siblings. So actually, you can count the number of siblings for each and every student, right? Like, for example, this guy has two siblings. This guy has one sibling, and this guy has 0 siblings. So that would actually make 0. That would make 2. 2 plus 0 is actually 2. 2 plus 1 is 3. So that means the total number of siblings in the class is 3. And it is actually discrete. So that's why this example over here is discrete. I think these are actually very easy terms. The last question, which will actually be the end of the video, is going to be the final question, and I'm going to do that in magenta, which is never in my color palette. There we go. Here's my okay. Yeah. So let's say that you have in your house a music player, right? You have the CD disc as well. So the number of songs you have, like let's say you actually have like three of them. Like you just have one here, two here, and you have another one over here, three. So over here you have three songs, three songs. So actually, the number of songs played per hour on a radio station. Sorry, actually, what I meant is actually you don't have a music radio system. You just only have like in a radio station. The number of songs played per hour on a radio station. So that means three songs played per hour. Is this discrete or continuous? Pause the video. You can actually go back and actually have to check if you actually got it right. Like you can see what is actually continuous and which one and what is actually discrete. And you can come back here and actually think about this for a second. This you think the first thing that might come to your mind is actually you say, oh, this is discrete, but you're wrong. It is something else. Just pause the video and just think about it. The answer is continuous. Why? Well, you could actually just see it again. You just have three songs, three music song on CD or whatever it is, per hour. I think some people have actually forgot to see that term here. Per hour. Three songs. So actually the number of songs played per hour. Per hour is actually sort of like more like the number of songs. So actually if I were to put up in a formula, you have the number of songs, number of songs played per the number of hours. So the number of songs, you know what, I'll just clear out that a little bit. Number of songs per 1 hour. 1 hour. But actually the number of songs divided by 1 hour. It is easy enough to tell that the number of songs, it's only just a question of asking the number of songs. You think, oh, it's discrete, but no. It's actually continuous because you have the term over here, per hour. I figured this would actually the end of this video, I should say. Hope you guys enjoy this video. Make sure you leave a like, please subscribe, and I'll see you guys in another video. Don't forget to be awesome, Herobrine. Before you go, I just want to show you guys something. If you guys just go ahead and subscribe to my YouTube channel, and if you actually do this, and if you actually get one of the discrete and continuous data correct, and if you got all of them correct, you can actually get this. You can actually get this huge, massive thing. This is the exact one. If you guys really want to actually just, if you guys really want it, you know what? I'll send it as an exercise file. You can actually get this one for free with my signature on it. Just ignore that. You'll actually get it with a signature on it. What I'm actually working on Photoshop is actually going to be an awesome Minecraft art. And if you guys really want to actually just have one of these art, you can actually go ahead and subscribe to my channel, and you can get this awesome exercise file. It is not in like this. It'll be in the exercise 5 that'll leave in the description under the description down below. I'll also leave the link, my Scratch account link, uh, uh, in the description down below, so that you guys can actually watch my I should say animations or my game, or check out actually the game and see if you and actually just check out if you could see if the link actually works, because I'm not really that sure if it actually works pretty much. But anyhow, thank you so much for watching this video. Please like and subscribe. um See you guys in another video. Don't forget to be the awesome Hero Brian.